All right, we are live on LinkedIn and we are going to talk about deep learning. We have a great panel here from KNIME. We have a whole team. We've got Rosaria Silipo. She is in Germany. We have Kathrin Melcher, also in Germany. Adrian Nembach in Germany, and Corey, who's sitting in Texas. So hello, everybody. Thank you for joining.
Hi.
Hello.
I think before we get into the topic of deep learning, let's just do a quick round of introduction. So Rosario, if you can go ahead and give one to two sentences about who you are and what you do, and then we'll kind of go around the horn.
Okay, so I'm Rosaria Silipo. I work as an evangelist. I'm the head of the evangelist group at KNIME. The usual question is what the evangelists do. So I see my role a bit as an educator. I pre-digest a topic and then I pass it along to the audience.
Maybe I go next. So hello, everyone. I'm Kathrin Melcher. I also work as a data scientist in the evangelism team of Rosaria. And as Rosaria said, one of the tasks we are doing is training or teaching people. So I also run a lot of courses for KNIME. And in addition, I also enjoy trying out new things, building new workflows, and then upload them to the KNIME Hub so that everyone can use them starting from there. Corey, do you want to go next?
Yeah, sure. So I also work for Rosaria. I'm just another one of the many. Also work for just about everybody else at KNIME from time to time. But yeah, so we do these trainings, we do talks, we just work on cool use cases and just kind of get into data science wherever and whenever we can.
Well, I guess I'm somewhat of an outlier in this group because I'm actually a software engineer at KNIME. I focus partly on developing new nodes and frameworks for machine learning in KNIME, including our deep learning integration, although I'm just like a small part of the whole team, obviously.
Okay, awesome. Well, thank you, everybody. And thanks for, for those that are tuning in right now, just letting you know if you're tuning in now, we're going to be talking about deep learning. But before we get into deep learning and all the questions that I have prepared, I wanted to ask, what exactly does KNIME do? And also, I'm pronouncing it correctly, right? Because I know there's an issue with the K and an N, and people get confused.
The K is silent. So yeah, no, it's pronounced correctly. It's KNIME. So actually, KNIME is the company, and the product is KNIME Analytics Platform. KNIME Analytics Platform is an open source, open platform for data processing and data analysis. So it takes your data from A to B, where A and B can be data collection, data manipulation, machine learning, deployment, visualization, so all the possible steps in a data science process. It's based on a graphical interface, so it's not based on script. So you just drag and drop blocks, that we call them nodes, and then the pipeline of nodes becomes the workflow, so your full application from the A to B that you wanted to have. It's not necessary to know, to have a programming knowledge to use it, because exactly of this graphical user interface. Right, and if you want to know more about KNIME Analytics Platform, you can go on the KNIME website, knime.com. Or you can, if you want to have a more hands-on approach to discover KNIME Analytics Platform, then you can go onto the KNIME Hub, where there are a number of examples you can download and readapt to your data and tasks.
Okay, sounds good. Thank you for that overview. And I think now is a good time to really jump into deep learning and maybe give another overview of what exactly is deep learning.
Maybe I can answer this question. So I would describe deep learning as a modern version of neural networks, which have been around for a long time already. The basic idea of neural networks is that you want to model a biological network using a mathematical function with many layers and many parameters. And when you train this neural network, what you do is you try to find the best parameters for this function for a certain task. And now with the computational power that we have now, we can actually also train deeper and larger architectures and also more complex units. And that's what I would describe as deep learning.
Mm-hmm. All right. So I know we also hear a lot about machine learning, and just wanted to get a sense if somebody can describe the difference between machine learning and deep learning, because they both have the word learning in there, but what is the real differentiator?
Yeah, so I would call deep learning a subset of machine learning. And that's a really popular topic to argue about in the data science community. What is machine learning? What is AI? What is deep learning? And everybody's kind of got their own opinion to some degree. But Kathrin kind of introduced neural networks there. Those have been around for quite a while. Came out decades ago, really, in their most basic sense with the multi-layer perceptron. And we've moved forward with a lot of new technologies in that way. But like even some stuff that's still only just coming into modern use, like LSTM layers, have been around since the 90s. It's really just that all of this deep learning stuff, we're getting deeper networks, wider networks, more complicated networks. And we just have the computers and graphics cards to leverage all of that and train these models now. So it's just kind of an advancement on old tech.
Yeah, absolutely. And, I think it would be really helpful if we can talk about some common applications that people might be able to relate to in terms of where deep learning is used. If one of you can jump in and talk about that.
Yeah, so there's like a million different regions where deep learning is used. I struggle to find a place where nobody's tried it, in fact. But some common ones are like text analytics. It's really great for defining sequences, looking at sentiment of text reviews. But I think one of my personal favorites is working with images in deep learning, because you really don't have a lot of alternatives at that point unless you want to hard code feature extraction information to pull data from the pixels themselves. So.
Yeah, and then for image recognition, what are some use cases where that could be helpful? I know a couple come to mind in terms of like maybe preventing theft or identification, but wanted to hear your thoughts.
Cory and Adrian, that's yours.
Well, actually in computer vision and image recognition, basically any application in the recent years in those areas were basically applications of deep learning. What comes to mind was very popular is self-driving cars, for example. So a self-driving car should be able to tell what kind of objects are on the street, how far are those objects from the camera, and how are those objects moving, what kind of posture does I don't know, someone walking on the sidewalk have? Will they in the next moment jump on the street, or will they just keep on walking? And all of that is theoretically possible with deep learning.
Another area that's really widely used is in medical stuff. So I've seen use cases with cancer classifications, use cases on scanning x-rays, looking for broken bones, just different things like that. Lots of different applications where you might need an expert, but you don't want to have to call them up every single time.
Another classic one is the face recognition, right? That's where the whole thing started.
Yeah, I mean, at this point, to open up my phone, it actually uses face recognition.
Right.
And you actually have to look at it. So it's pretty interesting, because I tried to do it with my eyes closed. That didn't work.
Yeah, my eyesight's so bad.
Underfitting.
Yes. Okay, so what exactly is it about deep learning that makes it so powerful that we couldn't really do these things before?
Well, powerful, that's really the question, what you mean by that. So what I really think is the most powerful aspect of deep learning is its extreme flexibility, so that you can actually apply it to all those different domains of computer vision, text analysis, genome analysis, basically anything that you can represent as numbers can be used with deep learning. And actually, you can even cross those domains. You can have an image, and then you have a network that actually creates a description of that image by just being fed that image. Another thing that is very powerful and tells deep learning apart from other approaches is that it really can deal with multitask setting. So the single network can perform multiple tasks. Before I talked about that, the network for the self-driving car that estimates how far objects are from the camera and what kind of objects are within view. And there you can actually have one network that does both things. And it turns out that usually having only one network that does both is more effective or more useful than and more accurate than having two different networks do those separately.
I think a big advantage is also the flexibility, right? You can build it as big as you want. You can make it smaller. You can make it with some intermediate layer that then you remove. So it, you can try a few different architectures and see if they work.
Okay, great. We do have a question from somebody who's joined us live, from Zaid. He's asking, how can deep learning improve the software testing field?
Software engineer?
Raise your hand. No.
Software testing, that's an interesting approach. I mean, what you can do is, so software is just text in the end. And there actually have been some studies around analyzing source code using LSTMs. I think Andrei Karpathy has a blog post where he trained an LSTM on the source code of Linux and then used it to generate new fake source. And you can, I mean, you could do something like you provide it with, you provide the network with a class or some source code, and you can train it. This source code contains a bug here, here, and here. And then theoretically, that should be possible to use that to find bugs. Whether that works better than existing approaches right out of the box, I'm not sure, but that could be one approach.
Okay. So the next question I had was, what are some challenges that people face or company face when they're working with deep learning applications? And also on that note, like, what are some limitations of using deep learning? I know it's kind of a two-part question.
So I think one challenge is what Adrian just mentioned. You need labeled data. So in the example Adrian talked about, you need labeled source code where you have a bug. And finding a lot of labeled data or collecting a lot of labeled data can be challenging. But actually, most of the deep learning applications need a labeled data set to train the network. And if you want to train a deep neural network with many layers, then you have many parameters, then you also need a lot of data. And finding a lot of labeled data to actually train your neural network, that is, I think, one of the challenges that people have when they start training neural networks. And another one is that neural networks are often like a black box. So it's really hard to interpret the model afterwards. So it is important for your application to decide to explain why a model made a certain prediction. That's also a challenge with neural networks, because in the end, they really are like a black box. And you put something in, you get a prediction, but you don't know why you got this prediction now.
So you need a lot of data, and it's a black box. So it can be, it can put people off because you can't explain what's happening, right?
Yeah. I think those are two challenges.
Yeah. They're so good at finding different correlations in the data that you have to be really careful with them, that you don't accidentally create a very biased model, which is true of a lot of different frameworks, but that's tell in a deep learning network.
Yeah, absolutely. Did you want to add something, Adrian?
Yeah, it's also when you train networks, you have to be very careful that you do your validation right, because even if you shuffle all of your labels for your training set, your network will probably arrive at almost the same training loss. But obviously, if this link is broken between the training examples and their label, then the predictions are actually useless in practice. But you won't even see that when you train the network. So you have to be extra careful. Overlook more details that can be costly depending on when you apply.
Okay, cool. All right. So next question I had was, if you could provide a few examples of the most widely used and innovative neural network paradigms.
Okay, so shall I start? So I am the older one here, so the oldest one. So my knowledge is I spent a lot of years. So I would say that respect to the past, the big innovation has been the recurrent neural networks. The recurrent neural networks is not that they didn't exist in the past, but they were so computationally expensive that at least I remember that I used a recurrent neural network for my thesis in 1992, so a long time ago, and the computers did not manage very well. We had a Unix station, and it took days. So I think the recurrent neural networks, making them work, actually being able to train them in a reasonable amount of time, is a huge improvement with respect to the past. Now, once that you are able to train a recurrent neural network, then a lot of the units that require the auto connection, then they become also, it becomes also possible to train them. So after that, then the LSTM units became possible. They were introduced at the end of the 90s, same problem with the computational expenses, but now it's possible to train them, right? So a lot of let's say, the most innovative paradigms introduced in deep learning are actually old paradigms that is now possible to train. So like recurrent neural networks and LSTM units.
Mm-hmm.
Anybody else wants to add something?
Well, I would say that's not necessarily true. There are some new paradigms that haven't been along for a very long time. Generative adversarial networks come to mind there. They were introduced in 2014. So they are actually from the deep learning hype. And the idea there is that you want to create a network that is actually able to create data instead of consume data and produce a prediction. So you want to give this network, I don't know, a vector of noise, and it produces an image, for example. The way this is trained is by having two different networks, one generator and one discriminator. And the generator tries to fool the discriminator, and they play this kind of game against each other. And in the end, your generator actually produces data that looks very real. So where is this used? Well, for example, for deepfake videos, you might have seen those on the internet. But maybe something that is not so negatively connotated would be basically the inverse task from what I described before, where I told you about the network that can extract a description from an image. You can now also have a network that actually gets a description and produces an image that fits the description that you use, as an example.
Speaking of generating data, I'm a little upset we didn't hear about the rap song generator.
Do I have to say that?
Oh, but it's so fun.
It's once they left me alone, and yeah, well, there was a network lying there and generating text, and then I decided to, well, nobody wanted to work with me that day, so I decided to experiment, and I started generating rap songs. So
oh my God.
they are fake, but equally insulting.
Oh, they were fun.
Wow, that's awesome. I love it. I'd love to hear some.
Oh God, no.
Oh no.
We are in front of people.
Well, you definitely have fun. I love that. That's awesome.
Yeah, they shouldn't leave me alone.
No. Guys, let that be a lesson to you all.
Yeah.
So,
But just
when you hear deep learning, a lot of times, people can tend to run away because it sounds like it's something complicated and, difficult to understand. So I wanted to know, what are some barriers to entry, and do people really need to know how to code, or is it that complicated?
So I'm going to answer the one about needing to code. So then KNIME has this integration with the Keras libraries, and the nice thing of KNIME, it has this graphical user interface. So you use the Keras library, and on top of that, we have the graphical user interface. So all the instructions from the Keras libraries become nodes in KNIME. So you just drag and drop the nodes for each layer of the network. You build your architecture. Then there is one node to train your architectures. You prepare your data. And then at the end, you have one node to actually execute the architecture on new data. So at the end, it's only just a few nodes, a pipeline of a few nodes to train the network. Inside each node, you have all the parameters. So which kind of loss functions, which kind of training algorithm, which kind of, I don't know. So all the different parameters for the network. So it's not necessary if you use the KNIME Keras integration, it's not necessary to code. About the other limitation, I think I let Kathrin speak. She has a very strong opinion about that. So
I wouldn't say so. So I think, so probably it's not a barrier, but what is good if you want to understand how neural networks work is some basic math. So in the end, it's always, in the end, you do need some linear algebra to understand what happens in a neural network and how they work, and also how optimization problems can be handled in general. And if you really want to understand what is going on while training the network, some math is definitely helpful. But if you use KNIME Analytics platform and you use one of the network structures, which someone could have a really similar use case, then of course you can just reuse it and don't worry about everything what goes on in the background if you don't want to understand it. So KNIME makes it really easy for you or to get started with deep learning.
Well, so I would like, now I make fun of Kathrin because she's the mathematician among us, but she's actually right. So it's easy to use. It still means that you need to understand what you're doing, right? Because otherwise you're going to use a cannon to solve a tiny, tiny problem.
Yes, absolutely. And I hear, there's a meme out there that says, here's a simple problem, here's a simple solution, and here's like the data scientist bringing in deep learning to try to
Oh boy.
to split a P or something.
So you still need to know what you are doing a bit, right? Yeah.
Yeah, but that's cool how KNIME allows you to use the drag and drop features to build the pipeline and connect the nodes and all of that. So that's great stuff, guys.
Yeah.
We do have a question from Camilo. Well, he says, what could be a nice alternative for time series forecasting now that LSTM are kind of old and expensive?
Yeah, so another option is to use gated recurrent units, which are also as old as LSTMs, but they are a bit easier to train and a bit less computational expensive. So that could be an option.
Okay.
Another option could be attention-based networks, although I'm not 100% sure how much they are used for time series applications, but they are very popular for text applications. You might have heard of the BERT architecture by Google. And well, in theory, text is also just a sequence, so that might also be useful for time series analysis. At least time series analysis where you have multiple features, basically, might vary at times.
Okay, just want to remind those that are tuned in live, feel free to jump in and ask questions. Anything on deep learning, the team here has you covered from every aspect. They can answer any questions, they promise. So, next question I had was, if you can share a couple of best practices for those that want to get started with deep learning, like what do they do?
So I can give one. So a lot of the time when people first get started with deep learning, they feel like they need to build their own custom network architecture. And while that's definitely one of the strengths of deep learning, is just the sheer level of customization you have when using this approach. You really don't have to all the time. It's okay to go grab architectures that other people have designed. It's okay to grab pre-trained models. Deep learning is a very easy way to apply transfer learning, for example. If you've got, for example, some of the ImageNet classifiers, and they've already been trained to extract relevant features from images, you can take architectures like that, maybe chop off the end and add some of your own classification layers, and then just kind of tune that final bit of it. So you don't have to start from scratch all the time. In fact, starting from scratch can be very difficult unless you've got lots of expertise and lots and lots and lots of data. So I would just recommend starting from that angle.
Well, and if you really have to start from scratch, then maybe something that I can attest to from experience is that you should start small. So before you create your huge architecture and throw it onto a gigantic data set like the ImageNet data set, start small. Try your idea in a small version, small architecture, and apply it to a small data set. Like, for example, MNIST or slightly bigger C4.
So you mean like on a
Or
toy
image.
example?
Yeah, like make sure your idea actually works, because it's crucial that you fail fast. If you first train your network for 3 days and then find out that you had a bug, believe me,
I've done that.
that's very annoying. So just start small, make sure that everything works for a small example before you scale up to large examples, where it also can get expensive if you have to buy computational power for it.
Right.
Yeah,
and
and
speaking of price, oh yeah, go ahead.
Go ahead. Yeah, I just wanted to add. Yeah, I agree with Corey that if you start with neural networks and you've never trained it, or you've never tried to train a neural network before, and you don't know the basics yet, what I can recommend is to look at some of the examples, at some of the blog posts, and try to understand the different steps which are people using, and then try to copy them to your own first project to get started, and don't start from scratch.
So something that I've learned, since it's the flexibility of the neural networks it's very easy to build a very complex architecture. And you never know if you're overshooting the problem, if it's too much, if it's just the right architecture, if it has to be bigger. So usually you start big when you start big, and then you use I've learned to use the dropout layer so that I can randomize the training procedure and avoid the overfitting.
All right. And before I go on to the next question, T. Scotland Daniel just wanted to say that he's glad to see that we've gathered the 9 gods and goddesses of today. So, that was funny, so I wanted to share. Okay, so Kathrin, you mentioned that looking at some examples of blog posts and neural networks. Where can people find examples of deep learning and neural networks that they can start with?
So we have the a KNIME Hub. You can search it on the internet, and the KNIME Hub is a repository of examples. So examples for everything where KNIME is used. So any kind of examples. One subset of these examples they refer to deep learning. So if you go into the KNIME Hub, you use the search term deep learning, then you find a bunch of examples. Those examples are built by us, Adrian a lot, Corey the ones for image processing, Kathrin for the time series analysis. I did the rep songs, you can find it there. But then it's also a lot of the examples created by the KNIME community. So not necessarily KNIME employees, but also the whole KNIME community. And there are a number of those, so you can find a lot of those. A subset of these examples on the KNIME Hub are also available on the example server. If you open the KNIME Analytics platform, in the top left corner, there is the KNIME Explorer where all your work is stored. And in the top part, you have a connection to the public example server. And then you can use these public examples. You can drag and drop them in your local workspace, and then you start working with them.
Okay, so outside of KNIME, are there other resources, maybe books or courses that people can take to kind of get started with deep learning?
There are plenty.
One or two.
Well, there are a couple of free courses that you can do on online platforms like I'm sure Sarah maybe, and a couple of others. But there are also very good courses on YouTube. So MIT just released the deep learning courses for this year, basically. A couple of, like in the past few weeks, they have been releasing new videos on their lectures, which are very good. Or, for example, the Stanford courses are very, very, very good. I can recommend those. They're also good.
The one that everybody takes is the one of Andrew NG on Coursera, right? So there are many of those.
That one isn't free, is it? So
well, it's
I don't-
Coursera. You need to be on Coursera. Yeah.
Yeah, I don't know.
Yeah,
but
that's
there are plenty.
Yeah,
that's a name I hear often is Adrian's name when it comes to this topic.
Yeah, that was the first famous course on deep learning. So it's actually, some of us have taken it, and it's pretty good. Yeah, of course you have to be on Coursera. Yeah.
Yep. Well, sometimes you pay for your education. That's, we're all gotten so used to free resources that.
So another book that we have used a lot is the Goodfellow book. That there are a number of authors.
Okay.
This one is another classic. It's one of the classics that you have to read. I mean, it starts from the origin of the neural networks, but it also covers all the recurrent neural networks, the backpropagation through time, the LSTM. So.
Mm-hmm.
Yeah.
Okay, there was a question here. I forgot who it was from, but it was basically around, there people compare deep learning and neural networks to kind of how our mind works. Can you talk a little bit about maybe an example of how, you can explain deep learning with how our mind is working?
Yeah, so this has been an attempt, let's say, to simulate the human brains. I don't know if we are able to. I think there was a tweet or a post some time ago that was saying that deep learning is now what we are as a 2-year-old toddler, or at least animal, or something like that.
I think I saw that one going around.
So I don't know how much similar the artificial neural networks are to the human brain. But one mechanism that has been copied, for example, was what Adrian was talking about before, is the attention layer. So that you focus on one part of the data, and then you shift this focus as to learn how they are all connected with each other.
Mm-hmm.
I don't know. Otherwise, the convolutional neural networks, maybe they somehow are inspired by human brain.
I think they work okay as an analogy.
Yeah.
Because, in your cells, in your neuron cells, you've got the neuron itself, of course, in the center. And, the signal runs down the axon, was it? It's been a while. Gets down to the synapses, and, maybe they fire, maybe they don't. And then a whole bunch of these connects to the next neuron. They kind of feel that input and decide whether or not they should fire. So in that way, you've kind of got all these recursive input outputs, where you get these values that come in, you've got some activation function that lives in the middle, and then it outputs something, and then you've got all these connectors just plugging in everywhere, and everything's just deciding whether or not it fires, and that builds.
Yeah, but in the convolutional neural layers now, you focus also on a portion of the image, and that's what, I don't know if the brain exactly does that, but that's what probably some brain does. And then, you just move again, you scan the picture, the image based on the focus that, you're using. So first one, processing of the image. I don't know how much that is close to the human brain. For sure, it's inspired from the human brain. I don't know, Adrian, do you have some more answer on that?
Well, for the CNNs, there is actually some analogy to the visual cortex, or actually for how our vision works. So there is something that was found. It's called a Gabor filter. It's very simple structures like edges or more corners, where we have neurons in our brains that can detect that. Or actually, I think it was on a cat, that experiment. That was a while ago. And if you look at the input layers of a convolutional neural network, then you will find that those filters that you have there actually also react to this kind of Gabor filter. So there is some kind of analogy, but well, it's not a one-to-one correspondence.
Yeah, I think it makes for a good analogy for people to kind of get a sense of how it works and what it is. So we do have another question from Camila Ruiz. It's asking, do you have any tips for data scientists who are new to the field in terms of building a valuable portfolio? Not everybody at once. Come on.
That's a fun one. I mean, I think a lot of the recommendations are to get out there and do stuff. I know that's cliche, there's a lot of like, what's the word I'm looking for? There's a lot of like
Competition.
I mean, there's Kaggle, of course, which is tons of competitions, but there's also like data science for good projects that a lot of people volunteer to work on as well, that are maybe closer to a real world application than competitions are. And you also get to give back to the community a bit, working on things like that too. So
Yeah, those are good suggestions. I know a lot of people go to Kaggle, and then data science for good is definitely a great way.
So my experience is maybe you focus on one of the problems. So let's say image recognition, because they're quite different on how you prepare the data. It's not. It's true that the neural networks, they work for all the data, but you still have to prepare them. You have to process them, and the processing requires different tools. So I would say you focus on one area, and then based on that area, you look for some examples, and then you experiment. For example, we started with the natural language generation. You can start from that one. You can start from the time series analysis, and then you can use the neural networks to analyze time series, or you can work on image processing. But yeah, so those are different domains and require different processing tools.
Okay, thank you. So I know you guys have a virtual KNIME summit coming up next week. I wanted to just, talk a little bit more about that. What are the dates? Where do people go to sign up to learn more? And what can people expect to hear in that summit?
I think Kathrin may have dropped off on accident.
So
should be a great different
Cory.
Yeah.
Hey. I'm back. Sorry, my internet connection was somehow lost, and now I was in the backstage area.
Oh, sorry about that.
I was listening to your great answers.
Okay, so we have the KNIME Summit. The KNIME Spring Summit was supposed to be live, but for obvious reasons, it's going to be online. It's going to be a virtual summit. So we are going to start on March 30th, 31st. It's going to be courses about KNIME, how to use KNIME Analytics platform for data scientists, for data wranglers. How to use it for deployment. So all the different courses. Then the 1st of April, we have a few talks. It's a subset of the talks we were planning to have in the live version. And then again, April 2nd, 3rd, we have more courses. April 2nd and 3rd, I and Kathrin, we will run the machine learning course. So if you want to attend, you can see us online again, virtual, for the machine learning course. You can find it. You can search KNIME Spring Summit, and you'll find it, and then you can register.
All right, great. And Kathrin, sorry about that. Glad to have you back on here right as we wrap up. So just wanted to thank you guys for, joining the panel, and those who tuned in live. I know we've gone a little bit over time. We're at 38 minutes now, but thank you so much for your time, guys, from KNIME. A great panel on deep learning. I've also learned a lot. I have a book on my desk right now on deep learning that I'm trying to learn the subject. So this was a great panel for me.
Do we get to know which one it is? Is that the recommendation still?
Yeah.
I have this book. So I got the John Crone book, Deep Learning Illustrated. I don't know if you heard of it, if you've seen it. It's pretty easy to get started with. It has a lot of pictures. So I'm loving that part.
They often help, yeah. Well, I hope I will. Sorry?
I said thank you for inviting us.
Oh, absolutely. It was great having you guys.
I hope I will see all of you virtually at the KNIME Summit.
Yes. And I hope to meet you guys in person one day, whenever we can leave our house again.
Yeah, whenever we can go out again.
All right. Have a good rest of your day. Thank you.
Thank you.
Bye-bye.
Thank you.
All right. So